So one of the ways that people calculate probabilities for the normal distribution is using the standard normal distribution and a table. It's a little more old school. So if you've taken stats before, you may have done this in your statistics classes. So if we have a particular z-score, we can find probabilities for it. So these are all, by the way, z-scores that don't fall onto our empirical rule. Remember, our empirical rule required that we basically were at 1, 2, or 3 standard deviations above or below the mean. So now we're going to be dealing with, as you can see, being 1.42 standard deviations below the average, which is not something we could have handled with our empirical rule. So for all of these normal questions, and this is required on the worksheet in class, it says it at the top, but you're going to forget to draw a picture, and I'm going to dock you points. Draw a picture first, because this keeps us from making all of the standard errors that you might make. So if we draw a picture, there are 3 things that I want on your picture. 1 is a normal curve. 2, whatever the mean for your distribution is. So now if we're talking about the standard normal, remember, the mean for a standard normal is 0 and the standard deviation is 1. Because if our z-score is 0, that means we're exactly at the average, and we're going out standard deviations, bunny hops of 1 in each direction. So I want you to have your mean. The third thing that you need is the area or region shaded that we're interested in. So in this case, we're interested in our z-score being less than negative 1.42. So negative 1 has got to be below 0. And if we wanted to be really good about this, we could think about our 3 bunny hops, right? And we could even think about our empirical rule. I don't care that much to have that on there, but you can use that to sort of space out where things are going. So 1.42 should be about halfway across our curve on that one side, because we have about 3 standard deviations to either side. So negative 1.42. And we are looking at less than. So the area that we're interested in is this area over here. So this is what that probability represents, this shaded area of our curve. Now, we can't just look at proportions because our curve is not evenly distributed like the uniform distribution. So this is where we're going to need something else to tell us this, and that's where our table comes in. So Professor Steele should have given you guys a table last class. If not, she'll give it to you guys this class. And that table should have looked something like this, just not in color. Sorry, that's a T. Should have looked something like this. And you can see it's drawn basically exactly like that picture I just had. There's a Z, we've shaded this section, and we're saying that the probability is the area shaded. So on that particular question we were working on, right, we were looking to see the probability of being less than 1.42. So that's exactly what we're going to do with this table, is we're going to look for less than, this needs to be negative 1.42. So the way this table works, as you can see, we've got z-scores here, and it's split up a little bit like a stem and leaf plot. You have the first 2 values of your z-score, so in this case are 1.4, negative 1.4, and then you have your last digit. So our last digit here is that 2, which is right there. And you're just going to figure out where those 2 pieces intersect. That's your probability. So that's how this table is set up. And that's all you have to do to find these probabilities. We've already got our answer, 0.0778. I like drawing the picture because I can actually sort of visually see, yeah, that's a reasonable amount of the curve. One of the most common mistakes is to grab the wrong side of the curve, as we'll see in the next ones. And so this lets us know we shaded less than half the curve, and my value was less than half, so I feel pretty good about it. And if you really wanted to be good about it, you could even think back to your empirical rule. Well, that's a terrible drawing, but you get the idea. This was 0.015, 0.1, oh my gosh. I think it's 0.135. It's been so long since I've done the empirical rule, I can't remember. And then what was this, 13%? So when we're here, we were at 1.4. We are less than 13%, but more than 5%. And you can see that's where 7% ends up. So that was a terrible explanation. But whatever. I don't like the empirical rule because it limits us a lot. But if we know the empirical rule well, it does give us sort of an idea of a reasonable answer. All right, so what I would suggest is trying now, pause the video, draw out the next 2 curves and see if you can figure out how to use the table to get those values. and then come back and check your work. So I'm going to assume that you've paused your video as you were told to do and have been badasses to think this out. So the next one, right, we're still dealing with our standard normal, still dealing with z-score, so we want to be centered at 0. I wanted a different color. No! Terrible things are happening. Pretend that's symmetric. We want our z to be greater than 1.95. So 1.95 is above 0. It's pretty close to that cutoff of 3, right? And we're interested in greater than, so our probability that we're looking for is here. So if you went to the table, one common mistake, especially if we're using the table, is to just, okay, well, we don't have a negative, so we can go all the way to the next page, which has our positives. And we can grab 1.95. We get 0.9744. 0.97. But if we've drawn our picture, we recognize right away that we've made a mistake because we did not shade 97% of this curve. In fact, remember the drawing at the top of that table shows that they're giving out left side probabilities. So if they gave us this side is 0.9774 and we know the entire area under the curve is equal to 1, then we can figure out the part that we're missing by just doing 1 minus. So 0.0256. So you could do that. Another option, so that's one option, is to just look up whatever the heck you're looking for and then subtract from 1 if necessary. The other option is you could just look up negative 1.95 because since this thing is symmetric, being above positive 1.5 is the same thing as being below negative 1.95. So that's sort of a shortcut if you want to think of it that way. If we looked up negative 1.95, boop, boop, that takes us directly to that 0.0256 without having to do the 1 minus. So it's really up to you which way you prefer, but either way works. And then the last one, again, if you haven't tried it, I suggest pausing because if you can figure it out on your own, it's way easier than just trying to memorize what I've told you. So we're still talking about z-scores, but now we're interested in our z-score being between 0.102, negative 0.102, and 2.57. So we got about 1 standard deviation off to the left to our negative 1, 2.5 standard deviations off to the right, 2.57, and we're looking for the area between. That's the probability that we're looking for. So if you thought about this one, well, probably went and looked up one of your values. If you look up 2.57 in the table as is, you're going to get all of this area, right? Which is just too much. You've run ahead and you've gotten all of this. It's exactly too much by this area. So what we're going to do is we're just going to subtract off the part that was too much, that negative 1.02. So if we take the amount to the left of positive 2.57, subtract off the amount to the left of negative 1.02, we'll get that leftover piece in the middle that we're looking for, right? The space between those two. So we're going to look up both as is and then just subtract those values from each other from that table. So go to my table. Already forgotten what the two values were. Positive 2.57 was one of them, I think, I hope. So 2.5 and 7 was the final digit. Be careful counting over because there's a 0 column and students always forget that, so they can be off a little bit. So I would recommend just writing on this. I have more, so feel free. You can use up your table on the test. I'll give you a brand new one. Write on it. It sucks to lose a point or two just because you were off a row or a column because you didn't want to write on the thing. So 0.9949 is the first value. Throw that down so I can actually check with the other ones. 0.9949. Where are my pens? There they are. I don't know how I moved the pens to this. There we are. So this is 0.9949. And now I need to figure out the extra bit, that negative 1.02. Negative 1.02. 0, 2, takes us to 0.1539. And if I subtract those two from each other, I'll get left over with the 0.8410, which is our probability we're interested in. This is not the only way to do this. I've had students also figure out the tail probabilities for both of these, sort of like we did on A and B, and then subtract those from 1. So there are other ways to approach this problem besides doing this. Look them both up and take the difference. Really up to you. Now, boo, sorry, I'm looking to see what I wrote down. I did not do what I wanted. I did want to point out there is a calculator shortcut for this to find the area under a normal curve. It is called normal CDF. So if you wanted to do that, I'll show you that in the next video. So if you want to see the calculator version, watch the next video.